Okay, welcome back to another video on the Maths channel. It's your teacher Muslim here, and in this video we're going to be looking at summing a geometric series. So by the end of this lesson, you'll be able to establish and use the formulae for the sum of the first n terms of a GP. So just to refresh our memories, the difference between an AP and a GP is that an AP is a common difference. So it's going up or down by the same value, whereas a GP has a common ratio. Okay, it's being multiplied by the same number. So let's have a look at this investigation. How would you find the sum of the first few terms in the following GPs? 2 plus 6 plus 18 plus 54 plus 162. Now, because we know it's a GP, we need to work out what the common ratio is. And we can see here that the common ratio is 3. Because 6 divided by 2 is 3, or 18 divided by 6 is 3, etc. So we know that the common ratio is 3. So what's another way of rewriting this series, this sum? Well, I can say the sum of the first 5 terms is equal to 2 plus 2 times 3 plus 2 times 3 times 3, or 2 times 3 squared, plus 2 times 3 cubed, plus 2 times 3 to the power 4. Now, because the common ratio is 3, technically, what I could do is I could multiply every single term by 3, each of these by 3. What do we get when we do that? I'm going to write that above it. 3 lots of the sum of the first 5 terms. Well, when we multiply this by 3, we get 2 times 3. When we times this by 3, we get 2 times 3 squared. When we times the next one by 3, we get 2 lots of 3 cubed. Next one, 2 lots of 3 to the power 4. And the last one, 2 lots of 3 to the power 5. So what we could do now is we could use elimination. We can subtract the bottom one from the top. 3 lots of the sum of the first 5 terms minus the sum of the first 5 terms is 2 lots of the sum of the first 5 terms. This minus this will cancel, 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 and cancel. So this will leave us with 2 lots of 3 to the power 5 minus 2. So if we want just the sum of the first 5 terms, that's going to give us 2 lots of 3 to the power 5 minus 2 divided by 2. I'm going to factorize the numerator. This will give us 2 on the outside, 3 to the power 5 minus 1, all over 2. Now I'm going to leave it at that. I know I can cancel these 2's, but I'm just going to leave it for now so that you can see the similarities between questions A and B. So what I want you to do now is I want you to pause the video, have a go with question B by yourselves. Okay, here's my answer. So I've got the sum of the first 6 terms is 3 bracket 5 to the power 6 minus 1 close bracket all over 4. Now let's compare these two answers. We've got this one here and we've got this one here. Right. The reason why I didn't cancel, I didn't simplify in question A, is because I wanted you to realize that it's a fraction. Okay, same as B. So what formula could we create to find the sum of the first n terms in a GP? How can we get this and this? Well, what does this 3 represent? Okay, that represents the first term. Okay, we can see that the first term is 3. What does this 6 represent? Well, that represents how many terms there are, same as this one. What does this 5 represent? Well, that's a common ratio. How do we get this 4? Alright, what about this one here? This is our first term. If we have a look, that's our first term. This is our number of terms that we're adding, same as this. This 3 here is our common ratio, but how do we get this 2? Well, we can see this 2 here. We got this 2 because we had to divide it. How do we get this 2? Well, it was 3 minus 1. There's a imaginary 1 here. How did we get this 4? Well, it was 5 minus 1. Well, the 5 is the ratio. So technically, this is the ratio minus 1. Okay, the ratio minus 1. So the formulas that we can create is the sum of the first n terms is equal to a bracket r to the power of n, let's do this, minus 1 over r minus 1. Or s of n is equal to a bracket 1 minus r to the n over 1 minus r. So there's 2 formulas that we can use. I mean, I've created this one in the investigation above, but really both of these are the same. You don't actually need to prove this. You actually have it in your formula sheet. So here's our formula sheet for the HSC, and we have it right here. There's that one, and there's this one. Okay, so you've got 2, but you need to know how to use it. So just remember, this is for an AP, this is for an AP, GP, GP, and later on we'll learn in a different video is the limiting sum of a GP. Alright, so when do we use which one? Well, I would use the first one. I would use this when r is greater than 1, when the ratio is greater than 1. So if we've got a ratio of 3, I would use that formula. When would I use this? I would use this when the ratio is less than 1. And the reason why I would do that is so that the denominator will always be positive. Now, it doesn't really matter which one you use. I mean, if the ratio was less than 1 and you use the first formula, you'll still get the same answer. So it doesn't really matter which one you use. Alright, let's have a look at some examples. Find the sum of all the powers of 5 from 5 to the power 0 to 5 to the power 7. So the formula, because we know that this is a GP because it's going, it has a common ratio of 5. So formula is S of n is equal to a bracket r to the n minus 1 over r minus 1. So we need a, we need r, and we need n. A is the first term, which is 5 to the power 0, which is 1. R is equal to 5. It's got a common ratio of 5. And n, how many terms are there? There are 8 terms. From 0 to 7, there are 8 terms. So that means the sum of the first 8 terms is 1 bracket 5 to the power of 8 minus 1 over 5 minus 1. Alright, let's put that in our calculator. 5 to the power of 8 minus 1 over 4, 97,656. Alright, question B. Find the sum of the first 6 terms of the GP, 2 minus 6 plus 18 minus etc. So, formula, S of n is equal to a bracket 1 minus r to the n. Actually, we'll do r to the n minus 1 over r minus 1. So what is the ratio? Well, first of all, the first term is 2. The ratio is minus 6 divided by 2, which is minus 3. Okay, or we could have done 18 divided by minus 6, also minus 3. And the number of terms is 6 according to this question. So you'll notice here that I'm using the first formula. When I've got minus 3 minus 1 in the denominator, I'm going to have a negative denominator, which is fine. I'm going to get the same answer. So I'm going to show you both ways. That doesn't matter which formula you use, it will still work. So we have 2 times the ratio is minus 3 to the power of 6 minus 1 over minus 3 minus 1. All right, let's put that in our calculators. Minus 364. Now let's say, for example, you used the other formula. S of n is equal to a bracket 1 minus r to the n over 1 minus r. We'll get 2 times 1 minus 3 to the power of 6 over 1 minus 3. So when we put that in the calculator, we get minus 364. Okay, so that shows you it doesn't matter which formula you use. If you want to just get used to one of them, that's fine. All right, question C. Find the sum of the first 10 terms of the series 3 plus 12 plus 48 plus etc. Have a go with this one yourselves. I'll get you to pause the video, and when you're ready to check your answers, you can continue playing it. Okay, here's my answer. So the sum of the first 10 terms is equal to 3 bracket 4 to the power of 10 minus 1 all over 4 minus 1, which is 1,048,575. All right, question D. The sum of the first 4 terms of a GP with a ratio of 3 is 200. Find the 4 terms. So sum of the first n terms, a bracket r to the n minus 1 over r minus 1. Sum of the first 4 terms. We don't know what the first term is. We know that the ratio is 3. And we know that the sum will be 200. So 3 minus 1, that's 2. I'm going to multiply both sides by 2, giving me 400. So the first term, therefore, is 400 divided by 3 to the power of 4 minus 1. Which is 5. So the first term is 5, so therefore the first 4 terms. First 4 terms. 5, because it has a ratio of 3, 5 times 3 is 15, 45, and 45 times 3 should be 135. Yeah. All right, question E. Find the formula for the sum of the first n terms of the GP, 2 plus 6 plus 18 plus etc. All right, why don't you pause the video and have a go with this one. Okay, so we know that the formula is Sn is equal to a bracket r to the n minus 1 over r minus 1. A is 2. The ratio here is 3. 3 minus 1, which is 2. The 2's will cancel, so it's just going to equal to 3 to the power of n minus 1. That's it. Okay, question F. How many terms of the GP in part E must be taken for the sum to exceed 1 billion? So we've got 3 to the power of n minus 1. That's the sum. That needs to be greater than 1 billion. So what I'm going to do is I'm going to add 1 to both sides. 1 billion and 1. Then I'm going to use logs. So n has to be greater than, I'm going to use ln. ln of 1 billion and 1 over ln of 3. So remember, this is our base, right? Base to the power. So that goes into the bottom of the fraction. Base, bottom. Alright, let's put that in a calculator. So ln of 1 billion and 1 over ln of 3 is 18.86. Okay, n has to be greater than that. Therefore, we need 19. 19 terms needed. Okay. Question G. Evaluate 2 to the power of n. We've got the sum from 3 to 11. So here, this is our, the first term is when n is equal to 3. And that will be our last term when n is equal to 11. So sum of the first n terms, a bracket r to the n minus 1 over r minus 1. So the first term is going to be 2 to the power of 3, which is 8. The common ratio is 2 because it's 2 to the power of whatever. So we can tell that it's going to double each time. So that means the ratio is 2. And how many terms are there from 3 to 11? It's not 8, it's actually 9, because we need to include the 3. 3, 4, 5, 6, 7, 8, 9, 10, 11, that's 9 terms. Now the easiest way to do this is to just subtract them and then add 1. Okay, so that's the easiest way. So you don't have to use your fingers to count. Just subtract them and add 1. That's how many terms we have. So what we really want to do is work out the sum of the first 9 terms according to this, where the first term is 8, the common ratio is 2, and there are 9 terms. So we've got 8 bracket 2 to the power 9 minus 1, 4088. And that's the sum. Okay. Just so that, to give this question a little bit more context, because you might not be familiar with this notation. Okay, what that means is we've got 2 to the power of n, where the first term is when n is 3. So 2 to the power of 3, that's 8. This here means sum, so we're summing all of these terms. So I'm going to write plus. Or the next one is when, well, actually it might be easier we do this. 2 to the power of 3 plus 2 to the power of 4 plus 2 to the power of 5 plus all the way until 2 to the power of 11, according to the question. Okay, so if we were to write it out as a series, that's what it would look like. Alright, question H. The sum of n terms is of 1 plus 4 plus 16 plus etc. is 21,845. Find the value of n. This time I might get you to pause the video, see if you can use your understanding of the formula and manipulate it in a way to find the value of n. Okay, so I'm going to write down the formula. S of n is equal to a bracket r to the n minus 1 over r minus 1. But we know the sum is 21,845, so 21,845. We know that the first term is 1. The ratio is 4. Okay, 4 divided by 1 is 4, or 16 divided by 4 is 4. To the power of n minus 1 over 4 minus 1. 4 minus 1 is 3, so I'm going to multiply both sides by 3 to get rid of fraction. 65,535 is equal to 4 to the power of n minus 1. I'm going to add 1 to both sides. 65,536 is equal to 4 to the power of n. And now because n is in the power, I'm going to use logs. N is equal to ln of the answer over ln of the base. Okay, remember, base goes to the bottom. Alright, let's put that in our calculators. And we get 8. And that's it, we found the value of n. So that means there must be 8 terms that we're adding together that would sum to 21,845. Alright, last one for this video. Evaluate 60 plus 20 plus 20 on 3 plus all the way up to 20 over 81. Alright. Maybe I'll get you to pause the video and have a go with this one yourselves as well. Okay. So I'm just going to write the formula. Sn is equal to a bracket r to the n minus 1 over r minus 1. We know a is 60. The ratio here looks like it's 1/3, because 20 divided by 60 is 1/3, so 1/3 to the power of n minus 1 over 1/3 minus 1. Now, I can't actually work out this sum because I need to know what n is equal to. I need to know how many terms there are. In order for me to do that, I need to recognize that the last term is technically the nth term. So I'm going to go back to my formula sheet. I'm going to work out, I'm going to see what the formula is to work out the nth term of a GP. So it's this one. This is the nth term of a GP, right? Nth term, T for term, S for sum. So the nth term of a GP is a times r to the n minus 1. Alright, now in this case, the nth term is 20 over 81. A is 60. The ratio is 1/3 to the power of n minus 1. So I'm going to divide both sides by 60. Giving me 1 over 243 is equal to 1/3 to the power of n minus 1. I'm going to use my logs. The power is equal to ln of the answer over ln of the base. Base goes to the bottom. And then whatever that is, like we can add 1. So ln of 1 over 243 over ln of 1 over 3 gives us 5. So n minus 1 is equal to 5. So n is equal to 6. Good. Now that we've done that, I can replace this n here with 6. And now we can find the sum, because we know technically there are 6 terms. Alright, let's put this in our calculator. 60 bracket 1/3 to the power of 6 minus 1 over 1/3 minus 1. 7,280 over 81. And that's the sum. About 89.88. Alright, so that's it for this video. I hope you now know how to find the sum of a GP. The formula is Sn is equal to a bracket r to the n minus 1 all over r minus 1. And we always need three things. We need the first term, we need the common ratio, and we need the number of terms that we are summing. Have a great day. I'll see you in the next video. Bye.